All right, so we got 1/2 absolute value.
Oh shoot, sorry, I did not know it was that blurry.
That's okay. It's good enough here. There's a 1/2. Absolute value 2 parentheses x minus 2 plus 1. There are 1, 2, 3, 4 transformations. Order does matter.
Yeah, so I remember we were doing a table kind of thing, correct?
You can you're the way I'm reading this though is they want the transformations. They want to know like, and again the way I show this, which is a little different than what you probably see in class. Imagine you put like 5 in for x.
Uh-huh.
What is the first thing to do here in terms of simplifying it?
Make it three.
Make it so you're subtract. So you're now looking at, since you said subtract, you're looking at the x minus 2. What's that transformation?
X minus two would be moving right by 2 units.
Right, by 2 units. So then you get that thing becomes 3. Then what's the next thing you're going to do here?
Move left by 3 units.
Nope, nope. You got this 2 here.
Oh, sorry, my bad. You'd have to vertically, no, horizontally. Um, mm,
So because it's different than the outside. So if 2 are on the outside, it'd be a stretch by 2, but since it's on the inside, it's a,
shrink by two.
yeah, it's horizontal as well. Then, since then you've dealt with all that, you got an absolute value number now. Do you multiply by 1/2 or add 1 to it first?
Um, I multiply by 1/2.
Okay, so what does that correspond to?
Divide by two, or
Uh,
divide y
stretch.
by, or divide y units by two.
Vertical shrink by, and then I guess you're allowed to say 1/2 here. It's really by 2, but I don't know. You got to have the word vertical. Vertical shrink, compress, stretch, something like that.
Uh-huh.
Then you got the plus 1 there.
And then that would just be moving vertically up by 1 unit.
Yeah, up 1. All right. So why do you think you got 4 graphs here?
Uh, because there's 4 steps in order to get the final answer.
Yeah, although they want you to graph the parent function, so you'd actually need a fifth of each
Uh-huh.
one. But you can start out with the absolute value of x, and then you're supposed to say, okay, now I'm going to do x 2. So you're supposed to, because you have this list, you're supposed to do them one at a time.
Uh-huh.
All right. So
So, um, so what you originally want to do is like do all the multiplication and stuff,
well,
like stretching and shrinking, and then continue on
I
because like that's
you
just
really
easiest.
you're supposed to do it in the order that it appears. Like my question to you is can you go right to the answer? And that's where making a table is the best approach.
Uh-huh.
What do you say? I mean, do you know, can we go right to the answer, final one, or do you have to show the intermediate ones?
I mean, I have to show all the intermediate ones, but I mean, I think I could probably, but I mean, I'm just gonna do all the intermediate just to play it safe.
Okay.
Because I showed her once, like I was like, "Oh, am I allowed to do this table thing?" She's like, "Oh, no, 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 you don't need to do that," or something like. I don't. She didn't say like I couldn't do it, but she's like, I shouldn't be doing it.
You should give them what they want. Okay. So that's where I'm not sure here. I'm lost a little bit in terms of how to like best help you because there's only 3 transformations. There's 4 total. Are we supposed to do each one? Are we
I think so. Yeah, I think she messed up the amount of graphs on it or something too.
okay? So the next one here is the horizontal shrink by 2. So that's 2 parentheses x minus 2 like this.
Uh huh.
All right. Any idea what that looks like?
Um, that would So in this problem, you're going to be dividing the x-axis or the x units by 2. And
Yeah,
then,
so it and it's you got to talk about it horizontally, which is a little, but it goes like this. Like it's more, hate saying it, vertical, but that's what it does. Kind of
uh,
pulls it in.
so, okay, so when I'm writing transformations, do I need to write like quite literally what it's doing, or can I just kind of write it
I'm not
like
sure.
that? All right, you know what? I'll just do both, honestly, because I
There's
didn't
not
even think about that until now.
there's not enough information here to tell you for sure. Um, I'm treating it like, okay, we've knocked out the inner one. Now we're going to knock out the next one. And then this next one here is 1/2 absolute value 2 x minus 2, which, believe it or not, undoes what we just did. So it's going to go back to the original because you're going back from the horizontal shift by 2, the vertical shift by 1/2. It pulls these points down. And so they go back to being kind of a flatter or more V.
Uh-huh. Huh, okay, so just,
So
yeah,
if you get the a number and a reciprocal, they do undo each other for the absolute value.
okay, so, I guess that's another kind of way to look at it. I think, I don't know. Do you think we could move on to just the next problem? I don't know what it is about. Just
Okay.
where it is right now. It's just like
Yeah,
something of those
sure,
numbers are not.
sure. So 5. All right, so here again, I see 1, 2, 3, 4 transformations.
Mhm.
All right.
So I see a vertical flip over the or I see a vertical reflection over the x-axis.
Yeah.
That's what I was trying to say. And
Okay.
I see a stretch of 2.
Okay. Vertical stretch of 2.
Um, I also see moving to the left by 4 units and moving up by 2 units.
Okay, good. What is the parent function? I probably should have asked you that in the previous one. What's the parent function here?
The square root, which is f(x) equals square root x.
Good. All right. So parent function here, we'll graph first.
And that's 1 1 2 3 4 9 or something like that, or
Yeah, I mean, are you supposed to be that? You said no tables.
um
I'm just asking.
oh, sorry, no, we have like, I don't know, just 3 different. I think we use like 0 0 4 and 2 and like 9 and 3 or something. Like, I'm not super sure what her numbers are. She's gonna have them up on the
Okay.
board for us. Or actually I might have a picture.
Sometimes you get the tables given to you, the parent function tables, and that's why I'm asking, just to make sure you've got them down.
Oh, yeah, I got those down.
Okay. I mean, I haven't said in a while. I'm only asking for your benefit. I mean, all of this is
Uh,
very, very clear.
yeah, no, I think most of this stuff is I don't know, like this, I guess what would I call this? Just like graph with parent functions, like
Yeah. So the first thing is to go left 4.
Uh-huh.
And it, like you said not to use a table, but really that is the way to do these. I mean, left 4
Yeah.
affects the x, -4, -3, 0, same
Yeah,
y.
like I still do the tables sometimes just as like, I don't know, verification in a sense, just because like I don't want to risk it, you know?
So it should look the same. It's just left 4.
Uh-huh. And then I have a question when I'm actually using
Go
those
ahead.
graphs. Am I allowed to do more than one transformation in the same thing as long as I label it?
That is the question I've been asking myself here. I think I think you should, but
Mm-hmm. You know what? I'll just say if I have 5 steps and only 4 graphs, then I'll do it. I guess. I honestly I don't really think it matters too much. She's pretty lenient with the way you do this. Like it doesn't matter the order you go in or anything as
okay.
well, which is nice, but also, you know, if you're trying to get it really well, not super nice, but
Yeah. So I mean I'm not trying to be difficult. I just like I really don't know because again, like you didn't get enough.
yeah.
Like you got like yeah, you can do more than one here, but the the order does matter, but if you don't want that, it's fine. Reflection over the x-axis means that all of the y values are negated.
Oh,
Okay. But we can also do a vertical stretch of 2 in this one. But
vertical.
that means multiplying all the y values by 2.
Yeah, I like the table. It's makes it easy.
Yeah.
Yeah, so I guess
Oops, that's the wrong direction.
and sorry, did you say we're multiplying this by 2?
Right. I'm including 2 transformations here. I'm doing 2 and 3.
Okay.
The
All good, all
reflection
good. I was
because
just making
these
sure.
both affect y.
Oh, yeah, might as well like kind of put them together. Like even with a X, you know, you might as
Yeah.
well do them at the same time as well if you can. Yeah, and then you get that, and then the next one you just would move it 4 units up and uh
So
2 units to the right, I think.
just up. So you're only affecting the y. The y is going up 2.
Yeah, and then that
You're
would be
adding 2.
2, 0, -2. Yeah, I was gonna say, it's like, I think you did your math wrong. I think that's supposed to be 2, 4, 6. And I was like, oh, wait a second.
Yeah, this is not right. What's going on here? Um,
Wait, is it not right?
this should be 2. Sorry, I got the wrong things again. Oh, there it is. Now it's fine.
All right, perfect.
They all have the same shape. They're just
Moved around a little. Yeah, I think the graphs, like I have a question when so in the instructions it says label label 3 points on each graph.
okay.
So is that like be the numbers?
That's the ordered pairs we've got here. Yeah.
Okay.
So
Yeah,
they
I'm just gonna do those tables with it too. Like,
yeah.
just makes more sense. Huh. Okay. Um. Yeah, I don't know. I like to be honest. Like, I mean, I got this down pretty well.
Okay. Well, what was
And
the issue
she's
then with
level.
what was the issue then with this one? Like why were do we need to do this with tables? Like what?
Um. Maybe I was like just misheard something. So it's like, all right. So looking at that one, or could I? Or here, I'll flip it over. That's problem 4, correct?
Yeah. And your parent function is
X,
-1 1 0 0 1 1.
and then yeah. So I guess. I would move it to the right by 2.
Okay, so that's only affecting X, 1, 2, 3.
And then I guess should I just keep going with the theme of the X and divide them by 2 as well?
You do divide them by 2 here, yeah. So, that's where it's like, well, should you have maybe chosen those values? That's a good question. Excuse me.
The yeah, so then 101. And then I guess you'd
So this,
I guess you
I'm
could
I'm sorry. Yeah. So the next one affects the Y values.
uh-huh. And that would be a shrink.
Yeah, you multiply them by 1/2.
A 1/2. Yeah, so then I'd just be cutting them in half, and then I guess you to top it off, you'd move them all up by 1 unit.
Yes, they all go up by 1, so the Y values go up by 1. So you could change this to 3/2, +1, and 3/2.
Okay. I don't know why I was struggling with that one. That's not too bad. Yeah, I think yeah, I don't know. This is I don't really know why we're doing this. Like I don't really think it's been fitting in with our themes of everything else so far.
Yeah, I mean, I don't have a comment, but
Maybe I don't know. I guess I mean like I got this down pretty well. I mean, do you have any guesses on what I might be doing in the near future, such as Wednesday or something?
um, not really. Your class is all over the place. Like, unfortunately, I don't have a good feel for that.
Uh-huh.
You're in geometry
I
still?
am. I
Well, I
am.
don't know why they're doing this, but they
Yeah.
are.
I almost feel like the teacher like gave us the wrong unit or something. I don't even know.
It does feel like, I mean, this feels like the stuff they get in algebra 2. Um,
Yeah, no, it's a pretty disorganized class. I just say that.
well, I mean, some other options would be SAT prep. Um, Other options, stopping early. I'm I really do you have your Google Classroom? Do you have your syllabus, maybe something that says like this is what's coming at you?
Yeah, I think I have a syllabus in my folder. I might just take a quick second to find just because there's a lot of stuff in there. I know like the classroom it was kind of weird at the beginning of the year because my teacher, she was she's from India and then she somehow got stuck in India until October.
Oh yeah.
And then we had like a substitute every single day that
Yeah, I
couldn't
remember
teach
that.
math or
I
anything.
remember
Yeah,
that.
nothing good. And they let's see. They
I
might
mean,
have given me a syllabus, but there's the issue is the classroom. There's just like no posts on it really. I mean, I can
that's okay. The traditional pathway for a geometry student is at some point you talk about areas and volumes and
uh-huh.
surface areas. That's your typical like last part of the geometry course.
Um okay, yeah, I mean, I guess we can do a little bit of that, right?
It's up to you. That's one direction you could go. You did do your right angle trigonometry, sine, cosines, tangents. Did you do all that?
Yeah, that all sounds very familiar.
Okay, so that's your other thing that I see a lot of. Um,
The areas, volume, surface areas. I think let's see. Here, I'm gonna open her classroom real quick and see if just by any chance she actually posted anything. Because maybe that could help us out. Yeah. I thought let's see. Yeah, the issue is she has 4 different what's it called? Geometry classrooms for this. So it's kind of like a little funky. So let's see, review plus key. I'm looking at because for a while we had another one of the math teachers teaching us,
Okay.
and I'm in his classroom. And it looks like they've just been doing okay, so it looks like they've been doing the same stuff as us. Graphing transformations, quiz review, key. Yeah, it's just all the same thing, I guess. Maybe we could. But were we doing like rotations before this?
We did some, yeah. That is something you see.
Maybe we could do a little bit of review on that because I guess I'll have finals are coming up in a couple weeks, I think, right?
Yeah, I mean you're 5 weeks to the end here. The rotations are pretty much formulaic. We look at the formulas, I give you some problems. Sure. I mean that's a good use of our time here. Let me pull up this reference sheet. I'll send that to you in the chat as well. It's really tough to do without this. So I mean I got another student in geometry at your school, but they are doing rotations, but
Uh-huh.
it's very simplistic. I mean,
Huh.
so
Yeah, I mean, maybe we could go over areas, value surface areas,
yep,
something like that.
we'll do a few of these. I'll snip them in as well. Just
All right. Do you want me to click what's in the chat?
you can. It's like a thing to print out, have with you when you're working on problems. I'll put it up here as
Uh-huh.
well.
Oh,
Uh,
I actually have this.
great. Oh, good. Well, so then you're already ahead of the game. I was just gonna give you a few of these to try. Uh,
All right. Yeah, might as well refresh my memory on that.
all right. So you got
Yeah,
that sheet
boom,
there.
found it.
So let's say I want you to over the y-axis -2, -5. What does that become?
Um, over the wax. Uh, am I allowed to use the cheat sheet?
You can. Here's another way to do it is to plot the point
Uh-huh.
and then plot the
Minus
new
minus
point
y.
and then decide how to do that. You are welcome to use the sheet. I mean
Oh,
this
so then that would become like 2 minus 5. So then I guess that would be changing the x into a positive. So or I mean, would you be having subtraction always as
it's
it like
it's
minus
it,
x?
it think of it as changing the sign.
Oh,
Okay. Um, so the harder one here, you've got those formulas in front of you, right?
yeah.
Or you can pull them up, is if I tell you what is, I say it's -3, 4, but it goes to 3 minus 4, is for you to decide which one is it. Is it over the x-axis, over the y-axis, over the line y equals x, through the origin?
So it looks like that. So it looks like there's some kind of uh going over the axis because both signs are changing. So I think it would be like x minus y is the change. Like xy goes to x minus y, and then no minus x minus y. Would that be going over the x-axis? I'm assuming.
So like what I'm asking you to do is say, like, this is x and y. So what happens here? What happens to x? It went from -3 to +3. What does that mean in terms of this?
It flipped over the y-axis, or I mean, reflected.
I'm asking you to put either, so here's some possibilities. Well, actually, I can you can put them all. It could be yx, it could be -y, -x, it could be -yx, could be X negative Y, negative X, Y. That's what I'm trying to get you
I
to
think it's negative x negative y. Is that possible?
yes.
Okay, then I think it's
That's what I'm
negative
asking
x.
for. And so which one does that correspond to?
Through the origin.
Yes. Okay. So those are, pretty straightforward here. Now the rotations are given at the bottom of this page. And I think I remember comments to the other student that your school had just, that whoever printed these for you guys had just taken them, like scan of this. They didn't even try to change them. They're just like, yep, here you go. Please give credit to, Tucker's middle school, not middle school, Tucker, uh, wherever that is in Georgia, like
Yeah, they snatched
whatever.
it right off them.
Yeah.
Yeah, I kind of remember you actually mentioning that. I sent you a picture of a couple problems or that, and you're like, oh, this looks familiar.
So, you got these rules again, like the first type of problem I can give you is tell you what the transformation is. I can say it's 270 degrees CCW, that's counterclockwise. And I give you -8, -6. And you have to tell me the new ordered pair.
Um, okay, so is this going, so this is going counterclockwise.
270 counterclockwise. You got to find that on that page there.
So that would be going xy becomes y minus x.
Okay.
And then that would become if it's y minus x, that would be -6 and +8.
That's correct.
And then
Okay, so here is the harder one is I give you an ordered pair like -1, -7, and I tell you this becomes 1, 7, and you have to figure out which one that is.
that is -x minus y. That's through the origin.
Think of it as a rotation.
Um, as like a, oh, my bad. That would be 180 degrees clockwise, correct?
Or counterclockwise, right?
Oh, yeah, they'd be the same because of
Yes. So notice, and this is this is one of those things you can get now because we've got some time here for some self-discovery, is through the origin is really 180-degree rotation.
Uh-huh. Oh, yeah, that's
They're
very true.
exactly the same rules. CCW, CW.
CCW, CW.
CW, the network for, I don't even know what's on the CW now. That's a joke. CCW is
Sorry, that
counterclockwise.
would remind me.
Yeah. Buffy the Vampire Slayer's on the CW. No, I don't know. That was from when I was a kid. The the so there's what's interesting, I guess, is that the one's a rotation, one is through the origin. They are the same. Okay. So here's a sample problem. Okay. That I'm going to show you something just in terms of your like processing. So let's say we want to do a 90-degree CCW counterclockwise on the following ordered pairs. Okay. So don't write anything down here. -2, 3, 2, -3, -2, -3, and then -3, -2. Okay. Those are the old ones. And we know the order is XY goes to -y comma x. Okay.
Uh-huh.
So if you have to do a bunch of these in a row, the way to do it is to look for the one that's the same. See how the x value becomes the y value?
Uh-huh.
So you do all of those together. You don't do it as an ordered pair. You go, okay, that's the X value from the first one. That's the X value from the first one. That's the X value from the first one. That's the X value from the first one.
Uh-huh.
The reason you do that is your brain can only do one thing at a time, even though we think we can multitask, really can't.
Yeah.
You're much better at doing the same thing over and over again rather than switching between two rules. So now we know we have to take whatever the Y value is and negate it. So it was 3, -3. It was -3, that's 3. It was -3, now it's 3. It was -2, now it's 2. Much, much faster than trying to do them because you're switching between two processes. You're switching between negate it Y, flip X, all that stuff. That's what I would recommend, is doing it kind of in columns. I don't know what you
Uh-huh.
think about that, but that would be kind of how I would do it,
Yeah.
especially if it's something that where the points are given like that.
Okay.
All right. So, I mean, I can go look for more questions now on this if you would like.
Yeah, I guess. Honestly, like I wouldn't mind trying maybe something new as well. Because
Okay.
this I kinda was like, oh, this is gonna be so hard to go back to. And I was like, oh, this isn't too bad.
All right. So let's start with area. Do you remember any area formulas? Let's just start there.
Um, I don't think so.
Okay. How about the area of a triangle?
Oh, wait, area of a circle is G parentheses. Okay, no, I don't. I know that it's relevant though.
Pi r squared, pi r squared. Triangle is base times height divided by 2.
Uh-huh.
How about a rectangle?
A rectangle is it like a squared plus b squared? No, it's
Base times
L
height, base times height.
base times height
So
divided
notice
by base
it's,
times height.
nope, it's just base times height.
Oh, wait a second. Yeah, if you got two triangles, that makes a rectangle.
That's right. I was about to show you that. So we'll do it here. See how it's two triangles. That's why it's base times height.
Okay. Yeah, wow. I didn't even think about
What
that till right now.
what is this?
Um, oh God, that's like it's not a trapezoid,
It's
is
not
it?
God. It's a trapezoid. It's a trapezoid.
Um,
All right. So it's the formula here is base 1 plus base 2 divided by 2 times the height. And you see that a couple of different ways.
man, I hope I
Right.
don't get that on my final.
Yeah, well, I don't know. That's what's these are all kind of weird. How about a parallelogram?
A parallelogram is all the sides are the same, I'm pretty sure.
That's a rhombus. Parallelogram is base times height.
Base times height. I guess yes, that is correct.
Okay. It's like I'm feeling like you've never seen these before, and I know that's not true because
I said yeah, like I know I've seen them, and I'm just like, oh man, like I like remember really specific things about them, and then it's like the wrong thing. I was like seen there, I guess.
all right,
Um,
all right. So what I'm doing now is finding a reference sheet for you that I like. Um,
did I do this possibly on first semester, like before Christmas, or
mm, maybe I thought you guys were doing proofs, but
maybe we were? Yeah, I'm not. Can't really
actually,
remember it
actually,
all too
this
well.
I like this one actually a lot here. Okay, I found a new reference sheet that I think I'll start suggesting to students. Okay, here's a good one. Um, let's go ahead and take a look at that.
So that's got like all the answers you could say.
Yes, that's all the formulas you'll ever need for this class.
All right, man. Yeah, I might need to print that. So
I'm
arc
look
length, man, I think that's what I was doing before, right? Like simple
possibly.
angle and stuff.
Yeah, that possibly.
Man, I forgot about that. That's kind of concerning. Um,
All right, let
yeah,
me,
that was let's see, that's I kind of remember doing that with you. I'm not sure how I did on that test actually, now that I start to remember that. Because does this all lead into kind of like central angle and stuff like that?
not particularly. I mean, usually you have a unit on circles or triangles and then a unit on circles. Circles are the area, the arc length, sector area, stuff like that.
Uh,
I'm
huh.
just trying to scavenger here for some problems for us to work on.
Yeah, for sure. Man, yeah, this is kind of like weird just seeing kind of stuff that you forget about that like, you did sort of.
Yeah, a lot of students do close out their year with doing uh, the area and volume.
Uh,
Do you have the volumes on there?
like on that sheet you sent me.
Yeah, yeah.
Um, some of them have volume.
Okay, maybe we can do
Or I think,
volume.
or maybe the ones that maybe because not everything can have volume, I guess, right?
No, no, no. Like, but you see, like, there's maybe some
Like a sphere has like
cylinders.
4/3 pi r
That's
squared
a sphere for that 4/3 pi r cubed.
cubed. That's what I was trying to remember.
All right, let me get some problems here. Let me think of the student who had these. What was her name? Oh, sorry,
No,
I'm
it's
trying.
fine. I mean, this is unexpected as.
All right, here we go. This will be a good place to start. All righty. Here's a problem to put in front of you. Finally found some that are good. What is the volume for the prism? So you have a formula there, formula sheet there, and I'm gonna grab it as well here. So you're looking at the one that says rectangular solid.
Rectangular solid.
So I'm going to put that up here. So you're looking at the rectangular solid. For now, we're just doing the volume. So you don't care about the surface area. You don't care about the lateral area. The volume is length times
Times
width
width
times
times
height.
height.
Yeah.
So then, okay, I'm starting to remember this a bit now. So
So you're going to take these three numbers and multiply them together.
and then is this where there's like the tan -1 like cos -1
No,
sine?
we're not doing any of that.
Okay, like
You're really gonna,
everything's like everything I've done has kind of just been like coming back at me in pieces, sort of.
I mean, we can do some problems like that, but this is volume is, I mean, this is the simplest volume problem you can get. You're taking the
Uh,
bottom number, multiplying by the side number, multiplying it by the top number here.
that'd be 8 times 1.5, and then I'll do the calculator for that real quick, just so I don't mess up something easy. So that would be 12.
Okay, and what are the units of volume?
Meters.
That's length. Meters are, single units are for length. Meters squared is for area. What do you think
Oh,
volume
3
is?
and 3
Meters cubed or cubic meters.
cubic meters. Cubed showing volume. All right, yeah, that makes sense.
Okay. All right.
Um,
Number two here. Sorry,
yeah.
do you have a thought for me? Sorry.
No, all good, all good.
All right. Why don't you try this one on your own, please?
Length time width time height. And does it necessarily matter what order you do it in?
So to answer your question, think about something much simpler, like 4 times 5 times 6. 4 times 5 is 20, times 6 is 120. 4 times 5 times 6, if we take 5 times 6, 30. 4 times 30. Do we get the same answer?
We do.
We do. So the order does not matter. We could even do 4 times 6 times 5, 24 times 5, which is 120. This is not a proof, but the order does not matter to answer your question.
Okay, all right. I'll stick to whatever seems easiest, I guess. Like I'd probably
Sure.
do 4 times 5 times 6, which is,
Where
you
are
know.
you getting? Oh, where are you getting those numbers though?
Oh, sorry, just like from your
Okay.
example, my bad. Yeah, and this one I'd probably do 6 times 11, 66 times 14.
Okay.
And then
You're allowed to use a calculator. So
all right, I'll go do that. 66, 924, M3.
okay. 924 meters cubed. I didn't check that. I'll just take your word for it. Okay, here we go. Go ahead and look at your sheet I sent over. Tell me what, well, let me look and actually see if it's on there. Oh, it is on there. Yes.
So that, let's see the sheet. That is a right prism. No, wait, what am I saying? That's a cylinder.
It is.
I was gonna
So,
say, I was like,
so
oh, it looks kind of.
it's not the, this is the one that looks nice to our eyes. It follows the golden ratio. This one is like, we don't like it. Maybe you
Yeah,
do. I mean, everyone's different. I mean, there's certain, there's
let's
certain,
say the hockey puck,
yeah. Um, what is the formula for the volume of a cylinder? What do you see there?
Radius squared times height.
Okay, so is your radius given in this problem?
Um, 1 second, I'm trying to remember what it's radius and what's the thing where it's from one side to the other, like from meeting from the middle?
The diameter?
Diameter. So two diameters make the radius, and we are given the radius, which is 26.8 centimeters,
That's
correct?
right. That's right.
So then, yeah, that would be 26.8 squared times 9.8. And then, I guess I should probably,
This is not the radius though. You got to cut it in half. That's the diameter.
um,
So your
wait, so you're
radius,
telling me I need to divide, when it's squared, that means I have to divide it?
no, when you have to get the radius, the diameter is 26.8. The
Oh,
radius is
sorry,
half of that.
I did not use my brain there. Yeah, no, so I have to get half of 26.8, and that would be 13.4. And then I would write pi 13.4 times 9.8. And then,
So 13.4 is your radius. Your volume is pi 13.4 squared. Your height is 9.8.
and then that's just the final answer for volume. Like I don't need to solve it.
You have to multiply that out.
Oh, okay. So, and I would obviously be squaring the 13.4, correct?
Yes. Now I'm going to put the multiple choice in front of you here so you can give me the correct answer.
All right. I hope it's like a very, very easy one.
You will need a calculator.
Oh, okay. All
The
right.
part of this is about you calculating it out. Like
All right. I didn't know if you're gonna say like
it's an important skill.
124.8 and like 5 or something like that.
Yeah.
All right, let's see. I'll start calculating that out. Is the pi that's also serving into this, correct? Is
Yes.
3.14?
Yes.
All right.
So you can use 3.14 if your calculator's a pi button. You can use that.
I think it's about 5,528.22 centimeters.
You got it.
So,
All right. I think we're going to stop here because we've really tried to squeeze everything we can out of
yeah,
this
this
lesson.
is